This is Build Up Your Understanding question 10 from Magnetic Effects of Current from the book Pathfinder. So let us see. The question is, there's a dumbbell. It is made up of made by fixing two particles in the ends. So you can see a thin rod here, and this rod is rigid rod. Length of the rod is L. There are two particles. They have unlike charges. This is positive. This is negative. Magnitude is Q. And it is moving in a region of space where uniform magnetic field of induction B pointing everywhere in positive Z direction is present. So you can see dots are mentioned here. So that means magnetic field is in positive Z direction. So at a particular instant, when the rod makes an angle theta with the positive X direction, this angle is theta, you can see. Now, that time it is rotating with omega k cap. So omega is out of the plane. You can see this is the direction of omega, and its center velocity is this Vxi plus Vyk. We have to find out net force and net torque about center of the rod. So let's see, how do we solve this? So first I am going to find out the net force. So to find out the net force, see, we are going to first find out net force due to the only translation. So what we will do in this question, we will find out net force due to translation velocities, then net force due to rotational velocities, and do superposition of both. So first now, due to translation, if you see, this velocity is the velocity of center of mass. Then in translation, what happens? Each and every point have same velocity. So every point of the rod have same velocity, including these two charges also. This is positive, this is negative. So this red arrow you are seeing, this is parallel to this vector. So this is a velocity V. And for positive charge, for negative charge also same velocity. Now use left-hand rule. This is the velocity direction, and then magnetic field is out of the plane. So that will give you the force direction as this. Right? This blue arrow will gives the force direction on positive charge. Now, if you apply the same left-hand rule on negative charge, since everything else remains same, velocity, magnetic field, since charge is negative, direction of force will be opposite. So these two forces will cancel. Right? I think you understand this. So here, net force due to the translation is 0. That we can see very clearly from the diagram. Now let us see what is the net force due to rotation. So for that, I have made this diagram. Due to rotation, the velocity, since omega is this way, velocity of this is r omega, r here is L by 2. So this is omega L by 2. Again, use left-hand rule. So when you use left-hand rule, then force direction on positive will be like this. And force direction on negative will be like this. Now again, see, here magnetic field direction is same, velocity direction is reversed, and then charge also reversed. Here positive, here negative. So finally, two negatives will make that positive. So this is the force, is also force. Now these two forces are in same direction. So you are going to get some net force due to rotation. How much will that be? F is equal to QV cross V. What is the velocity? Velocity is this. Magnetic field is out of the plane. Angle is 90. So sine theta is 90 here. I have directly now written here the force vector. So the force is what? On this, I'm writing force on one charge plus Q and multiplying by 2. You can see direction is same. So what is that? Q V, velocity is omega L by 2. It is QVB, right? Here theta is 90. This theta is, sorry, I should not write this as theta. I should write this as alpha. Or I will just write 90, because here the velocity, which is the velocity, and magnetic field angle is 90. So sine 90 becomes 1, velocity is omega L by 2, magnetic field is B, and then now force is along the length of the rod. This angle is theta, so along this rod, what is unit vector? Cos theta I cap plus sine theta j cap. So that's it. This is the answer for net force acting on the rod. Now to find out net torque, what should we do? So let us see again this diagram. See here now, we can consider this diagram once more to find out the torque. Now, due to rotation, net torque will be 0. Why? Because these two forces about the center will not produce any torque. See, line of action of this force is passing through the center. Line of action of this force is also passing through the center. So net torque due to rotation is 0. Net force is coming due to what? Translation. But net torque is 0 due to rotation. Fine. Now, and let us see in this diagram. In this diagram, one force was this, one force was this. So this was due to translation. Due to translation, net force was 0. But net torque, what will be net torque? Net torque will not be 0, because if you see, if you take the center, then this will provide clockwise torque. This will also provide clockwise torque. So torque will be added. So what I'm going to do now, I will find torque on this positive charge by doing R cross F and then multiply by 2. Because this will also provide the same amount of torque in same direction. So let us calculate that. I have drawn the same diagram again here to calculate the net torque. This is the diagram. This is the direction of force. This forms a couple. So F into this distance also you can do. So I will write in vector form so that it becomes easy. Torque is equal to R cross F. F is QV cross P. This is R. So I have taken this as R, which is L by 2. And then I have to multiply by 2 also because same amount of torque will be acting on this. Now this 2Q comes out and then R cross V cross B. So this is triple product. I have used the formula of triple product, right? You study maths also, so you know this formula, you're familiar with this formula. So this formula is R dot B. Now R dot B, what is R dot B? R is in this direction, B is out of the plane, R dot B becomes 0. You are left with only one term, R dot B. So what is R? Now I am writing R in vector form. R is this vector, see in the diagram, which is length of this vector is L by 2. So in vector form, it is L by 2 cos theta I cap, L by 2 sin theta j cap. This minus is carried over here. And then now this is R, this is V. V is Vxi plus Vyj given in the question. Magnetic field V as it is in 2Q. Why this 2 is coming? Because there are same torque is acting on minus Q also. So after that, this 2 and this 2 will cancel. Just the calculation now. You can take this dot product and then B is in K cap direction. This minus is carried over from here. This is the answer for net torque, right? So the point is that due to net torque is coming due to what? Translation motion, but net force is coming due to rotational motion, fine. So that was my analysis. If you like this analysis, please hit a like button to this video and please subscribe to this channel also. Thank you very much. All the best. I will be back with next video. Thank you.